Hi, welcome to my channel pibyme Maths. This is by Devan. In this video, we'll be looking at February 2020 Pure Math 1 paper. Let's look at question number 1. This is from integration. So first write it as integral 8 over 3x cubed minus 1 over 2. Put the x power half into the top. It becomes x power minus half minus 5 dx. And then integrate it. So it's 8 over 3 x cube over x cube becomes x power 4 over 4 minus half. X power minus half plus 1 is positive half over positive half minus 5x plus c. And you cancel 8 and 4, that's 2. The half and half can be cancelled, so you're gonna get 2 over 3 x power 4 minus x power half minus 5x plus c. That's all. Just an easy 4-mark question. Question number 2. Given that y is equal to 3 power x, express each of the following in terms of y. That means we need to write this in terms of y or in terms of 3 power x. So you can replace 3 power x by y. So I'm going to write it as 3 power x to the power 3. It's same, right? When we multiply the powers, we will get 3 power. 3 power x is y, so you'll get y cube. That's all. For b, you can write it as 1 over 3 power x times 3 power minus 2 using laws of indices. You put this 3 power minus 2 on top, it becomes 3 power positive 2. 3 square is 9, 3 power x is y. That's the answer for part B. Part C now. 81 over, write it as 9 square times 9 power minus 3x. 9 square is 81, so you can cancel it. Put the 9 power 3x on top, it becomes 9 power positive 3x. The base is 9, but we need 3 actually. So I'm going to write 9 as 3 square to the power 3x. Using laws of indices, we multiply the powers. That's 2 3s are 6x, which is same as 3 power x power 6 is y power 6. That's all. Question number 3. We have a curve parabola given and a point P of 3, 16. Figure 1 shows part of the curve with this equation. Point is given. Find the gradient of the tangent to the curve at P. To find the gradient, you need to differentiate the function. So you will get 2x plus 3 when you differentiate this. And if you want to find the gradient at a particular point, you replace x by the x coordinate of the point. So gradient is equal to dy over dx at P of 3, 16. So 2 times 3 plus 3, which is 6 plus 3 is 9 is the answer. Part B now. The point Q with x coordinate 3 plus h also lies on the curve. Okay, we already have a point P of 3, that means this is 3. Now 3 plus h. So let's say the point is here. This distance is h, this is 3 plus h, so q of 3 plus h, we don't know the y coordinate, also lies on the curve. Find in terms of h the gradient of pq. So you need the y coordinate of q. When x is 3 plus h, you sub in x is equal to 3 plus h into the original function in this function, x square plus 3x minus 2. X square plus 3x minus 2. So open the bracket, a plus b whole square, a square plus 2ab plus b square. Open the bracket, 9 plus 3h minus 2. Simplify the like terms, h square, 6 plus 3 is 9h. And 9 plus 9, 18 minus 2 is plus 16. That's y coordinate. So the point Q is 3 plus h, h square plus 9h plus 16. And we know the point Q, which is give point P 3, 16. Now the slope of PQ, that's what they want you to find. Y2 minus Y1, so 8 square plus 9h plus 16 minus 16 over x2 minus x1. So you get 8 square plus 9h over h. You take h as a common factor from the numerator and cancel it. Therefore, the answer is h plus 9 is the answer. That's the answer for part B. Okay, I have taken part C here. Just a one more question, but I need to explain it properly. Explain briefly the relationship between the answer to part A and part B. In answer to part A, the answer is the gradient at P is 9. P is 9. Answer to part B is the gradient of PQ is 9 plus h, right? Okay, I'm going to explain this by copying the figure here. Okay, I have copied the figure here. This is the point P with x coordinate 3, and then point Q is here. The x coordinate is 3 plus h. This distance is h, right? This is point Q, 3 plus h, comma 8 square plus 9h plus 16 is the y coordinate. When you move the Q, the point Q along the curve, in this direction, what will happen? Let's say the Q comes here. Now the h becomes smaller, right? And the Q comes here, the h becomes much smaller. So when you put Q on top of P, basically h is 0, right? So when h tends to 0, this is how we write. When h tends to 0, what will happen when you put h is equal to 0 here? The gradient of PQ is equal to 9, which is same as the gradient of 9. What is the gradient of P at 9? It's a gradient of a line, a tangent line at P. Let's say we have a line here, not this one. I'm going to draw a tangent line at P. Okay. The gradient of this line is 9, right? But the gradient of the line at Q, is 9 plus h. When you move the point Q along the curve, the gradient becomes this, the tangent line becomes this. When you move, comes here and then comes here. Slowly, the orange line will be same as the blue line when Q aligns with P. That means the gradient of PQ becomes the gradient of the tangent at P. So all you need to write, when h tends to 0, gradient of PQ is equal to 9. That's all. Question number 4. This is from radians now. We have a diagram given. Figure 2 shows the plan view of a house ABCD. ABCD is a house actually. Okay. And then a lawn APCDA. This is a lawn actually. Okay. Let's read the question further. ABCD is a rectangle with AB is equal to 16. AB is equal to 16. So DZ is also 16. This length DZ is also 16. And then APCOA is a sector of a circle with center or radius 12. APCOA is a sector with radius 12. So this is 12. OC is also 12. The total length is 16. So if this is 12, this will be 4, right? Okay. And then point O lies on DC. As you can see, as shown in figure, point O lies on DC, right? This is the point O. Okay. Show that the size of the angle AOD is 1.231. AOD, they want us to find this angle. This is, since it's a rectangle, it's a right angle triangle. You can use SOHCAHTOA because you have the adjacent angle, you have the adjacent side, hypotenuse. So you can use cos theta. So you just write cos AOD is equal to adjacent over hypotenuse. So AOD is equal to, use radians mode, cos inverse of 4 over 12. 1.231 radians to the 3 decimal places, but I'm going to store the actual value as a. So 0.95 dot dot dot, and then write 1.231 radians. I put a little reference here, I stored the value as a. Let's move on to part B now. The lawn is shown shaded in figure. As you can see, the lawn is shaded, right? Find the area of the lawn in meter square. So I'm going to put the figure here. Okay, here is the lawn. We know this angle. We know this is 12, this is 4, the total length is 60. This also 12. They want us to find the area. We can find the area of this whole sector. The area of the sector, half r square is 12 square times theta. Theta is this whole angle. How do you find this whole angle? We know this little angle, and we know this angle on a straight line is 180 degree of pi. So pi plus this, pi plus the angle we calculated here, 1 point, don't use the rounded figure, use the actual. That will give you the area of the sector. Okay, I'm going to calculate the area of the sector now. 12 square times 1 over 2 times pi plus, I stored the angle as a. You get 314.8 dot dot dot. Do not round the figure. We will round only the final answer. So I'm going to store it as B. This is B. Okay, we got this whole area, include the right angle triangle. But to find the shaded area, we have to minus off this triangle, right? So the shaded area is equal to the whole area of the sector minus the area of the triangle. Half base times height. Height is this actually, which is square root of Pythagoras theorem. Use Pythagoras theorem. So we have stored this value as B. So B minus half times 4, 2 times square root of 12 square minus 4 square. They want the answer to 1 decimal place, so it's 292.2 meter square, because everything is given in meter. Okay, I'm not sure whether we will need this value later or not, so anyway I'm gonna store it as C. So just put a little reference here. Let's move on to the next part, part C. Find the perimeter of the lawn to 1 decimal place. So I have put the diagram here. They want the perimeter of the lawn. Lawn is this actually. So you need to find this arc length. This is 16. We know this length also. Using Pythagoras, you can find this length. Square root of 12 square minus 4 square. But to find the arc length, the formula is arc length, or you can just write it as perimeter. Perimeter is equal to, the arc length is, the radius is 12, and this theta is pi, this is pi, and this one we calculated in part A. So r times theta, 12 times pi plus that particular value, a body 1 point, don't use the rounded figure, 1.230 dot dot. So we got the arc length. We got this arc length. And then this is 16 plus 16 plus this length, which is square root of 12 square minus 4 square using Pythagoras theorem. So 12 times pi plus, I stored the value as 8, plus 16 plus square root of 12 square minus 4 square. We want the answer to one decimal place, 79.8 meter. That's all. Let's look at question number 5. Find using algebra all solutions of this. Take x as a common factor. You'll get 20x square minus 50x minus 30 is 0. Equate it to 0 separately. And this equation, if you divide through it by 10, it's going to be 2x square minus 5x minus 3 is 0. And then use your calculator straight away, get the value. 2 minus 5 minus 3. You get 3 and minus half. X is equal to 3, x is equal to minus half. Right step here, x minus 3. The minus half, write it as 2x plus 1 is equal to 0. That's all. It's an easy 3-mark question. Part B now. Hence find all real solutions. Okay. In part A, we got 20x cubed minus 50x square minus 30x is 0. When you compare these two equations, in the place of x, you have y plus 3 power half. So what we are going to do, we are going to take the solutions of this. There are 3 solutions. 0, 3 minus half. And replace x by y plus 3 power half. Y plus 3 to the power half is 0. Y plus 3 to the power half is 3. Y plus 3 to the power half is minus 1 over 2. Okay. For the first one, square both sides. Y plus 3 is 0. Y is equal to minus 3. Here square both sides. Y plus 3 is equal to 9. Y is equal to 6. Okay, here you cannot just square it because there will be no solution for this actually, power half. So whenever you get x square is equal to a negative number or x power half is equal to a negative number, you should write no solution. If you are wondering why there is no solution, I can quickly explain that. It might look a normal equation. When you square both sides, y plus 3 is 1 over minus 1 over 2 whole square, and then y is 1 over 4 minus 3. It looks like a normal one, right? But whatever solution you are getting here, when you sub in here, you won't get equal to minus half. Okay? And then in P3 you are going to learn about functions. If you look at square root of x, this is the function. We don't take the bottom part actually. We take only the top part. That means square root of 5, it has to be positive 5. We don't get the negative solution here. Only positive values. Otherwise, it's not a function. So do not worry about all this thing. Whenever you see something power half is equal to a negative number or something square is equal to a negative number, write it as no solution. So the solutions are minus 3 and 6. Question number 6. The line L1 has equation L2 cuts x-axis at this and is parallel to L1. So let's find the slope of L1. 3x minus 4y plus 20 is 0. Bring 4y to the other side. 4y is 3x plus 20. So y is 3 over 4x plus 20 over 4. So the slope of L1 is 3 over 4. Since L2 is parallel to L1, they share the same slope. And L2 passes through this point, so you can write y minus y1 is equal to slope times x minus x1. This point is x1, y1. And they want you to write it in this form where ABC are integers. That means you cannot have a fraction. Multiply through it by 4. 4y is equal to 3x minus 3 8s are 24. Move 4y to the other side. 3x minus 4y minus 24 is equal to 0. Part B, the line L1 cuts x-axis at P, y-axis at Q. Given that PQRS is a parallelogram, find the area of the parallelogram. We know the equation of L1 here. 3x minus 4y, 3x minus 4y plus 20 is 0. That's the equation of L1. When you replace x by 0, you're going to get minus 4y is equal to minus 20, y is equal to 5. That's the point. It cuts y-axis. That's why we put y-x is 0. So q of 0, 5. When you put y is equal to 0, 3x is equal to 20 minus 20. X is minus 20 over 3. That's the point P of. That's the point P. We have PQ here. R is given here in the previous part. So let's draw a diagram to understand it. So we have the point PQ and R is 8, 0. Okay, let me just draw a quick diagram to understand it. Minus 20 over 3. That's point P. 0, 5. That's point Q. 8, 0. That's point R. Is it 8, 0? Sorry. It should be 8, 0. So 8, 0 is R. 0, 5 is Q. I'm going to connect them. We have a triangle, but the question says PQRS is a parallelogram, find the area of S. So let's assume there is another point here. We don't know where the point is, just assume it's here. They are talking about this parallelogram. They're talking about this parallelogram. Okay. To find the parallelogram, area of the parallelogram, you can find the area of this triangle times it by 2. So area of PQRS is equal to 2 times the area of the triangle PQR. Half times base is PR times the height. Height is the distance from O to Q. So 2 times half times the distance here, it's 20 over 3, here it's 8. So 8 plus 20 over 3 times 5. 8 plus 20 over 3 times 5. 2 and a half will be cancelled. 220 over 3 meter square. Now square units. It's not given us meter. The last part, find the coordinates of S. Okay, I have put the figure here. So we are going to find the coordinates of S. So I'm going to explain this, listen to me carefully. Let's say we put a ruler here, a stick here. Okay. And then what I'm going to do now, I'm going to move this stick along QR. Okay, all the way to this point. So what will happen when the Q becomes, when we move Q along this line, when Q becomes R, P becomes S, right? The point Q is 0, 5, becomes R. Now, R is 8, 0. So the point P, which is minus 20 over 3, 0, becomes S, right? So you need to compare this and see what happens. 0 plus 8, right? So we need to add 8 to the x coordinate here. So S of minus 20 over 3 plus 8. And then for y coordinate, 5 becomes 0. That means minus 5. So you need to put minus 5 here. 0 minus 5. That will give you the x. 8 3s are 24. So it's going to be 4 over 3, minus 5. That's called vector translation method. So this is the easiest way to find S. That's all.